Here we have an object of mass m is on the inside of a truck, and the truck is accelerating with some acceleration a. So the mass of the object is given here, 0.5 kilograms, and the acceleration of the truck is going to be 3 meters per second squared. So the situation is that because the truck is accelerating, the object is on the end of the string, and it stays suspended at a constant angle. So the first question is, okay, what is this angle that the mass is suspended at? In order to do that, we consider the forces on the mass. So first, on the horizontal axis, we have the tension of the mass times the sine of the angle. Remember, the angle is given here. So the side of the triangle opposite to the angle is a sine. So we have m times the acceleration of the truck, because that's the only acceleration on the horizontal axis, equals tension times sine of theta. And on the vertical axis, we have the only force is the weight of the mass. So mg is the vertical component of the tension, which is just t times cosine of the angle. So what we're going to do to find the angle, we're going to divide both of these equations to get rid of the t, get rid of the tension. And if you do that, we obtain an equation for the tangent of the angle is equal to the acceleration of the truck over the gravity acceleration. And with this, you can solve for the angle. You can do arctangent and find that the angle is 17 degrees. So now that we know the angle, we can solve for the tension of the string. So for simplicity, we're just going to take the equation for the vertical axis, and we're going to do some algebra to solve for t, and we find that t is given by the mass of the ball, the gravity acceleration over cosine of the angle, and remember the angle we found it to be 17 degrees. And plugging all of that in, we find that the tension of the string is 5.12 newtons.